Good morning. Please take your seats and welcome to beautiful Valencia with a sunny day today for the plenary of the CAMS General Assembly. I'm very happy to see numbers back to pre-COVID level, to see this nice group. And before starting the event, I have just a few housekeeping information. If I could have the slide. Yes, so it's an event which is hybrid, so it means that we have almost a matching number of participants online, which means that speakers, please stay fairly close to the microphone so that people online can follow. So we will have, of course, coffee and lunch breaks, and you are all invited, so no need to go running for food, so all is covered. And tonight we will have from 6:30, we finish at 5:30, from 6:30 onwards, we will have a reception, and very importantly at the beginning, at 6:30, we will make the group picture. So please be back a bit before 6:30 tonight so that we're all on the picture. So we will have this plenary in a conference style, so there will be no big time for discussion, but for each talk, if the speakers respect the speaking time, there will be time for a few questions. For online participants, what we will do is that we will note down the question that they will send, and we will answer them offline in the next days. Importantly, in our day and age, the social media is a way to share information, and on Twitter we have hashtag CAMSGA23, quite creative. Please don't hesitate to share your thought about the event. And very importantly, we are just starting, but already thinking about the end. We will be very grateful if you can feedback by completing the post-event survey. So we will remind this at the end, but if some of you have to leave earlier, please complete this survey. It's good, it's valid for people on site, but also for people online. And finally, you can write down what you want, but we will, of course, record and make also the presentations available so that if there is something super interesting that someone said in the day, it will be available on the website shortly after the event. So now it's my pleasure to give the floor to Maria Berdal from European Commission, DG DEFI, who will formally open the 7th CAMS General Assembly.
Thank you. Thank you, Vincent Henry. Thank you, everyone, for being here and being online today. Good morning. I am Maria Berdal from the European Commission. I'm the program officer for CAMS, which means, more or less, that I'm your contact point to the European Commission, and I'm also the European Commission's contact point to CAMS. So, the world is constantly changing. Geopolitically, economically, we have the energy crisis and, of course, the climate crisis. But CAMS is also changing, responding increasingly to the different parts of the Green Deal and other EU policies. Some examples within the Green Deal is within the mobilizing industry for a clean and circular economy, where the CAMS methane monitoring is key. Then for supplying clean, affordable and secure energy, we have, for example, the solar radiation products for solar power plant planning, and maybe a bit lesser known, within the accelerating the shift to sustainable and smart mobility. We have the CAMS data products on anthropogenic and volcanic aerosols to ensure safe and efficient air route planning. This agility of CAMS makes my job easier in communication with other parts of the European Commission and other DGs. One of the largest users of Copernicus is and should be the European Commission. And last year, we mentioned here at the General Assembly that we experience an increased interest and number of requests from other DGs and other units within the Commission. We receive, of relevance to CAMS, a lot of requests on emissions, and more specifically methane emissions, where the upcoming CO2 MVS will support, and also other greenhouse gas emission monitoring capacities. Here, international collaboration is also key, and we foster a collaboration with WMO, for example, and the greenhouse gas monitoring group there. And we also continue to write Copernicus and CAMS into EU policies and directives. Some recent examples are the National Emission Reduction Commitment Directive, the NEC Directive, the Net Zero Industry Act, and the Ambient Air Directive. So these days we will hear a lot about recent developments and future developments in CAMS, such as the new CADS, the combined climate and atmosphere data store, and also the new cloud computing capabilities. Yesterday, we had the first meeting in the Atmosphere User Forum and got a summary of some of the results of the National Collaboration Program in CAMS. This is an important part of keeping Copernicus a user-driven program. And what really hit me yesterday was the differences between all of the countries, which I think that this collaboration program will benefit from, and it could really be a fruitful collaboration both between CAMS and member states, and also in between member states. And then we have the Copernicus thematic hubs. Right now, 4 thematic hubs are starting up, and later today we will have the launch of the health hub. And this is also an important element to reach new user segments and enhance interaction and collaboration. So one last point to mention is that this year Copernicus is celebrating 25 years. And CAMS has been there, or has been an idea at least for almost 15 years. And yes, just keep up the good works. I wish you all an excellent General Assembly, and I'll see you around. Thank you. And now, since I'm also the chair of this session, I would like to welcome to the stage Fernando Belda from EUMET, the Spanish Met Service. Please, the floor is yours, and your microphones are there.
Okay, thank you very much, Maria, and they are distinguished colleagues. Indeed, here, Januel Tapol, Director of Januel Tapol, I don't know if the pronunciation is correct, Director of Copernicus, Maria, obviously, and Vincent Henry, Director of CAMS, and obviously all distinguished colleagues here. Good morning, everybody. As you know, we are preparing excellent weather here in Valencia. My staff is there. The head of regional office, where is the head of regional office? Is Jorge, I don't know where is Jorge. Anyway, they are, he has been working during the night to ensure that the weather conditions for the next couple of days and the weekend will be excellent. I think, thanks my staff. On behalf of the President of EUMET and the staff EUMET, I would like to express my sincere thanks to CAMS for organizing here in Spain, in Valencia, the 7 CAMS Assembly. Thank you very much for your confidence, and especially for me, because I'm from Valencia, and then I'm very happy to be here, and then I have 2 reasons to be happy here. Thank you very much. Yesterday, we had an excellent opportunity to enhance the CAMS Spanish users. Yesterday's session was a clear example with several use cases were shown in the presentations, and obviously, and more important, the future collaboration was established, and future projects, future ideas that we can develop together with the public and private sector, and I'm sure that we can strengthen this collaboration to develop, in this case, CAMS products. 1 week ago, EUMET launched the State of Climate 2022 in Spain, and I want to take advantage of these 5 minutes that I have here to highlight some figures that we need to consider during these 2 days. The year 2022, I'm talking in Spain, was the warmest year in Spain since the beginning of the historical series in 1961. Warmer than 2017 and 2020. Of 10 warmest years in the series, 9 belong to the 21st century. I think that we know this, but it's not only in Spain, but this is data, this is observations. Summer 2022 was extremely warm, 3 heat waves with a duration of 41 days of heat waves, 41 days, higher than 2015 that we have 29 days. During this period, 35 daily warm record. And then this is important to consider this. Obviously, talking about the sea temperature was highest value since 1940. Precipitations 2022, if we have the ranking, is the 6th in the dry ranking, and in the 21st century is the 4th. Heavy storms registered, and that is not necessary to explain, because yesterday we have a good example here. When we have heavy storms in the Mediterranean area, is really, really important. But not only this value. Going to the CAMS business, I say, no. Sunshine duration, the insulations. In 2022, we registered 3% higher than the average value for the period 1983-2010. Coming back to the presentation yesterday, we have with energy, maybe it's fine because we have 3% higher than, but I think we need to consider. CO2, and taking the reference of our atmospheric observatory reference, as you know, in Ithania and Canarias Island, the annual difference from 2021 to 2022 is 2.2 ppm, which show in average value an average annual growth of 1.9 ppm since 1984. Methane, using the same observatory, and we have from 2021 from 2022 to 2022 an increase of 13 ppb. Nitrous oxide, annual increase of 1.3 ppb. Sulfur hexafluoride, molar fraction of more than 1.3 ppt parts per trillion. All is increase every year. These are observations. But obviously, due to the foreseeable effects of the climate change and its variability, these impacts are very likely to increase in the future, especially in the Mediterranean region, whose coastline is the most vulnerable to increase its flooding impacts, especially due to the flash flood caused by torrential rains that we have with the example yesterday. Analysis, diagnosis, and then forecast is neat. CAMS is our reference. I want to say CAMS is our reference. But we have our responsibility in the national meteorological services and obviously the government. We must reduce the emissions and drive to more sustainable growth if we want to follow the Paris Agreement and European Green Pact. It should be complete, obviously, with the measures that the Spanish government is promoting on green recovery policies. I want to talk some words regarding the health, because this afternoon we have opportunity to talk about health. Air pollution is one of the main risks to public health. A major report with data from 2019, you can find a lot of numbers, figures in the publications, place it as one of the most important causes of death in the world, accounting more or less 12% of the total death. More than factors like high blood pressure, dietary risk, high blood glucose, and smoking, and so on is important. Another important aspect that we need to work, and we are working in EUMET, is to reduce the gaps in the observations. We need to ensure that at least in situ, we need to make some effort and to invest additional resource to ensure that we have a good in situ observations, because satellite observations is another business. But we can do this, is to invest and to consider and to convince our politicians that we need to invest in the in situ observations. To conclude, we have several missions. We need to act. We need to act. We need to reduce the gap in observation that I said, systems in situ and satellite. We need to facilitate to the space agency that we have at national level to ensure that we are this focus in our business in the environment. We need to support early warning. Early warning for all this is quite an important project for WMO, and I may need to lead in Spain and in Ibero-American countries, and support the greenhouse gas watch that we know that CAMS is will play an important role in this initiative in WMO. Working together and looking ahead, I think with the new advance, we will be able to meet and fulfill the performance requirements with more cost-effective approach and fruitful. And I wish us a fruitful assembly, and obviously enjoy the city, because we are preparing excellent weather. Thank you very much for coming here. Thanks.
Thank you very much, Fernando. Our next speaker is Director of Copernicus Services from ECMWF, Jean-Noël Tepot.
Thank you, Maria, and good morning, everyone. Thank you, Fernando, and your colleagues, of course, to help us organizing this event here in Valencia. And thank you for the weather, especially last night when we had an interesting walk with Vincent to reach the restaurant between the drops. It was fun. So I have a few messages I would like to convey this morning. The first one is I cannot stress enough the importance of this type of general assemblies, both for CAMS today and for C3S, which ECMWF is also managing. Of course, there are a lot of exchanges, there are a lot of contracts, there are a lot of discussions, NOAAs, and so forth, but this is the opportunity for all of us at ECMWF to meet together, because we are located in 3 sites now. So it's not, although the center of gravity of Copernicus staff is in Bonn, we still have a few staff everywhere, so it's good for us to meet, but it's also excellent to meet you all and to discuss in an informal basis with you about the progress and how things are moving forward. So very important to have these general assemblies, and it's good to see that it's growing. Of course, there is the post-COVID effect, so everybody wants to mingle again, but I hope that it will continue like this. A few messages about ECMWF. We are in the phase of reorganization at ECMWF, and the goal for us is to integrate even further the Copernicus activities, also the destination Earth activities that we are not going to discuss today, but into the existing architecture of ECMWF. So in terms of impact on the activities, I don't think it will matter too much, but it shows for the ECMWF management the importance of considering this Copernicus as part of the, or as an integral part of the ECMWF operations. And I think that this reorganization will be completed by the end of the year, and we'll have a new structure beginning of 2024. 2023, so this year, is very important for CAMS, in my view. First of all, it's the first global stocktake, and it's really pleasing to see that although we don't have a dedicated mission on CO2 yet, and our colleagues from the space agencies will tell us more about what to expect in the years to come. There was already a paper proposed to the UN FCCC involving colleagues from ECMWF and colleagues from LSE and other groups. So that's good that this community is already providing some support to this effort. The National Collaboration Program, which probably will be discussed and maybe has been discussed yesterday already, is also something very important, and it was basically born with CAMS. And I understand that we have 9 contracts which are signed or to be signed, and we have 28 in the pipeline, so expressions of interest or even more. So it shows how important this activity is, because it's really bringing the community together, and this notion of co-design means something which is important to us. Now, another point which CAMS should be happy about is how lucky you are with the kit in space coming up for providing the services that the users require, with the Sentinel-4 and Sentinel-5 coming. So again, we'll hear more about it hopefully soon, and the CO2M, which is one of the expansion mission, which is the most secure, I would say, in the Copernicus program. The last point I wanted to mention is the midterm review. So next year there will be a midterm review of the Copernicus program, so Copernicus 2, as we call it, and preparations are already underway. So it will be an excellent opportunity for all of us, so ECMWF and all the partners and all the contractors to shine and demonstrate how vital the services we provide to the institutional users is. So this is very important. We need all of you, because you are contractors, but you are also ambassadors among your member states. We also have representatives from the user forum. So it's very important that we can demonstrate how important the core services are. I mean, it's not by chance that overall we have more than 200,000 users on the data stores at ECMWF. So we need these users to voice how happy or how better we can do, but it's very important that these messages are voiced. So this is my main messages. So I wish you all a good 2 days of discussions. As I said at the beginning, these general assemblies are crucial for us. We need the input, we need to exchange, and we need to make things better in the future. So enjoy the 2 days, and again, thank you for the for the location. It's a fantastic view. I hope that people will stay concentrated with the talks, because sometimes you may be distracted with such a blue sky outside. Thank you very much.
Thank you, Jean-Noël. So we're moving on to the introduction by the director of CAMS, Vincent-Henri Puck.
Thank you very much. So I have the privilege to start the presentations. And what I will do is basically to jog through the past year. So this is some of us last year in Bonn, and the subtitle of my presentation is what has happened since. So I have quite a lot of slides, so I won't go into detail, but it's a way looking chronologically at the year to basically stress different aspects of the service and how CAMS has, in particular, communicated to the outside world. So the first thing that we did last year was to publish a paper in the Bulletin of the American Meteorological Society about the first year of CAMS. So it's very important because for the scientific community, it's a way to mark a milestone. And already, although the paper is just 1 year old, we have lots of download and lots of people. When I meet people in the US or other continents, they use this as a reference. So it may seem anecdotal. It is not. It's really important to have this. So very glad we could do that over the summer. And now moving to other things, something that happened in the summer, which was not a first, but it had been more than 10 years now that CAMS is contributing to the state of climate that the Bulletin of the American Meteorological Society is providing, especially with a number of products. In the case of the 2021, which was the scope of this report, the impact of wildfire in Siberia was particularly marked. So it's very important that global is done in Europe with a strong focus on European Commission, European countries, but it's also a reference worldwide. Going through the year, so this was September, maybe you remember the Nord Stream leaks. So this was a big challenge for us. So many of the colleagues at ECMWF, Anna Agusti, at LSE, Frédéric Chevalier, at NILU, have been working on this case, which was very complex because this burst of the pipeline happened with a fully overcast sky. So there was no way to use satellite meaningfully. So we saw the importance of in situ observations, so working also especially with the ICOS research infrastructure, and using modeling to try infer what was the amount of methane in that case that was released through the leaks. So that was a very high visibility event, but also making us remember that Copernicus works best when it's on its 3 foot. One is satellite observation, one is modeling, data assimilation, and the third is in situ observations. And we will see in the rest of this session talks about both satellite and in situ. A big milestone for us at ECMWF was the change of operations from Reading to Bologna. So it happened in last October. Seems ages ago, but that was then. So you see our computer. Maybe last week, if you saw the Copernicus 25-year event, you saw Mark Pynton showing this room to the delegates. In the autumn, we had a very meaningful and useful policy user workshop. I think it was the biggest policy user workshop that we had with over 100 participants. The number is not that impressive, but you have to consider that these are really the people making the policy at national level. So that was very important. In particular, also the European Commission, DG Environment in that case, and DG GRC were present, and that's where we started to discuss how to move within the new air quality directive and to help countries use CAMS information, in particular to offset a natural contribution, and we will have a presentation on this in this meeting. November was COP27. Richard Engelen, Deputy Director of CAMS, has been together with C3S colleague Carlo Buontempo very active, lots of events, lots of visibility, and it's very important to connect with UNFCCC, with the countries. We have already some products that are useful, as Jean-Noël was mentioning, and this was a good opportunity. We are arriving to the end of the year. It was, again, 3 years in a row, a very unusual ozone hole. It was quite large, was not record large, but quite large. But what happened in the last 3 years, 2020, 21, and 22, is that the ozone hole closed much later than we usually saw. So it's not that the ozone layer recovery is derailed. No, it's that the meteorological condition in the stratosphere and the stability of the polar vortex has been much more stable than in the past. We think that it's related to climate change and to the fact that the stratosphere is cooling, so there are more polar stratospheric clouds in particular. But it also shows the strength of the combination of C3S and CAMS, because we have this very nice plots from our colleague Mia Ratzinger, showing the extent of the ozone hole since 1979, showing the, unfortunately, the buildup of the ozone hole, and the fact that even if the maximum was in the 2000s, we're still not yet seeing a very clear decline today on the ozone. We see a clear decline on the ozone depleting substances. January was a very important milestone. We had new projects starting to develop the next gen CAMS. So it's a Cameo working on the reactive gas aerosol part of the program, preparing for the new space instrument coming soon. And also Corso working on further development of the CO2 MVS. And trying to use additional observations to disentangle the natural and anthropogenic part of the CO2 emissions. So it's very important to have these elements. It's a big evolution compared to COP1. We are very fortunate to have that. We're also very fortunate to have a project which is also developing in the area of the emissions and surface fluxes. It's a SEEDS project, which is now in its second year. It's led by Leonor Tarasson, with many CAMS players in it. And many of the activities in SEEDS will make their way also into CAMS. End of January, a very important milestone. It's a big room at WMO. This was a conference organized to shape up a new initiative, which is called now Global Greenhouse Gas Watch. It's modeled on the example of the World Weather Watch, which led us to where we are for weather forecasting today. The ambition is to lead to operational greenhouse gas monitoring in the coming years. And what's really interesting, you can maybe spot quite a number of Europeans on this slide, but not only Europeans, US, Asian colleagues. Copernicus is really having a very substantial contribution to this worldwide initiative, tying in again with the UN system. Then we had the usual round of atmospheric composition events. Dust episode started in February. This is one that affected the Iberian Peninsula, sweeping through Portugal, Spain, and then going eastward. I'll jog very quickly. Something really meaningful for Spain were a very early start of wildfire with very big fires in Asturias, unfortunately, which are both, which were seen in March with a record in our time series from 2003. It's both a combination of the dry and hot conditions, but also on lighting the fires that caused this thing. So Copernicus and CAMS is Europe's eye on Earth, helping Spain in that case to try manage the situation better. And I pasted this. It's just recent. It's what's ongoing. It's fire in Canada. You've seen probably you've heard about these. Since May, they have been raging all through Canada, and this is a very frightening picture that Mark Parrington produced. It's about emission from fire, carbon emission from fire in Canada. You can see the spaghettis of the emissions along the months for the past year, since 2003, and you see the 2023 line, which is going on its own upwards, and unfortunately, there is no clear process why it should not be a very big record, because yeah, it will be mostly winter that will stop this situation. So it's really concerning. And then these massive plumes of wildfires have been traveling, and the CAMS system shows really its skill, not only in terms of aerosol optical depth, but also in terms of surface concentration of PM. And maybe if we have so much impact in the media and news, it's because New York City, for instance, has been affected by this. I don't have time to show, but the CAMS global system captured pretty well the surface PM 2.5 concentration in this case. So we are engaged on this big timeline of setting up emission service within CAMS, as Jean-Noël was mentioning. CO2 emissions, really clear, yes, but also emissions of other greenhouse gases. So we are going there. On the way, there are milestones which are really important. The first one I would like to mention is Germany using CAMS information for the report to UNFCCC. So that's the first country doing that. We really encourage more countries to do that. It's really the mark of success that Copernicus and CAMS is taken up in this. Jean-Noël mentioned this joint contribution of COCO2 and CAMS for the first global stocktake exercise. Also very important, and showing that, yes, we are all waiting for CO2M, but we have already some very relevant product for the Paris Agreement. Final two slides. One is to say that we have revamped considerably the presentation of our training offer, so it's more accessible. So there is a single web page where you can see all the very rich offer that we have. Chris Stewart is here in the room, showing all the different trainings from Jupyter notebooks to events to MOOCs, and our next event, jointly organized with ESA and EUMETSAT, will take place in Austria, in Innsbruck. It's an area where we work really well with ESA and EUMETSAT, making sure that people interested by atmospheric composition really have the best of the satellite and the modeling and in situ components. Final slide is to say that, yes, as Jean-Noël was mentioning, the NCP has become real. Last year it was bubbling and things, so you see these bars of color with the contracts that are signed, those in negotiation. So we really want to go to the 29 countries, so we are really serious about that, to have a CAMS national collaboration program in each and every of the Copernicus country, EU 27 and the 2, and there will be an account of that by Christina Nanasso tomorrow. Thank you very much for your attention.
Thank you, Vincent Henry. I understand that it's very hard to fit all of CAMS' work, even in highlight format, into 10-minute presentation. Now we're moving on to updates on the Copernicus space segment. And I think, okay, we're starting with ESA. So Klaus Zenner, the floor is yours. Okay, so maybe we'll
I think I prefer slides with the ESA logo on it.
Yes, so I think
I just feel more comfortable.
Would be an interesting, exercise. But I think we're starting with Federico then.
Okay. No, but there was a logic that we start from ESA side, because he will talk more about the future missions, and I would start.
Switch
it would be good
slides?
if we can change it. Is this complicated? If it's too complicated, we can also change.
Looks like something's happening.
Yeah.
Yeah.
I think we can overcome these technical problems. Thanks, Maria, and thanks for all colleagues from CAMS having invited me. Still waiting that my slide is coming up. But I will give you a short presentation about where we are with the space segment, with the Sentinels. And as I'm working for the European Space Agency, I will concentrate my presentation on the currently Sentinels that are operated by ESA. Still waiting for the slides. maybe my file was now deleted. Here we are. So here, just a few words on where we are with the Copernicus missions currently operated by ESA. The satellites building the space segment are Sentinels. ESA is responsible to build them. They are operated by ESA and also by EUMETSAT. So the operation of the Sentinels are being shared. So what's the status here? We launched the first Sentinel during 2014, was a Sentinel 1A. And what is the key here for this space segment, that for different themes, we do not have only 1 or 2 satellites, we have constellation of satellites. So for example, Sentinel 1A we launched during 2014, and 4 satellites are being planned. The same for Sentinel 2, 3. Sentinel 5B, the B stands for precursor. There will be a follow-on Sentinel 5 missions, 3 of them. And having these constellations, you get data sets that are covering a time period about 35 years, providing a stream of consistent, continuous data sets that can be used by operational services. This is really the basic idea here, to provide sustainable data streams that are feeding into operational services, and these services are financed by the European Commission, and on Atmosphere, the most important one for us is CAMS. We also have a problem here. You see this one part in the slide, it's red. One Sentinel stopped working. This happened about 1 year ago. We are now trying, we have a 1C in storage, and it's planned to launch 1C by the end of this year. What is also beside the Sentinels we are listed here, we have also started activities within Copernicus on the Copernicus contributing missions, and I will show you one slide here at the end. It's important for methane measurements. Few words on Sentinel 5B. It's clear I don't have to introduce to you this mission. We just had recently our 5 years anniversary. It was during October last year. The mission life design is for 7 years, but we had a very successful launch. So based on the fuel, in theory, we could operate the satellite for additional 13 years. So far, we really had nearly no anomalies, so you really have to knock on wood, you have to be careful. So far, everything is going well, and we have the funding by the end of 2027. We are providing 13 different products to the users. And quite recently, we performed a reprocessing campaign of all the products. So what we did in the past, we did upgrades of products, and when you do an upgrade, it's always, we do it only when there's significant improvement in the products, but we did not have the possibility to reprocess. We solved this recently. All our products have been reprocessed, and you get the data. They are now a homogeneous, consistent data set, so you don't have jumps between different version numbers. That's the key message here. We have, as I've mentioned before, these 13 core operational products. We're also developing so-called pre-operational products. We have 6 of them available within PAL. What I'm showing here is just one example where you see how air pollution can move over the globe. This is just a SO2 emission from a volcano, from a Russian volcano. And actually, the SO2 plume is going really around here, just as an example. Just the status on the Sentinel 5B products. I'm only talking about the core products. We will include a new information into sulfur dioxide, the aerosol layer height. This is information requested by CAMS. So we really try to fulfill what CAMS is asking us. For the reprocessing, just an example, we also put our priorities on which species we reprocess based on CAMS feedback. So really there's a close interaction, and we try to make our user here happy. We are also working on a new methane processor. We are flying with a Sentinel 5B behind a Suomi MPP. We are using cloud information in the methane processor, so we are depending on it. Suomi MPP is old. NOAA 21 has been launched. We'll replace it quite soon. So we are trying to find a solution not to use any more Suomi MPP data, to become independent. Right now, we cannot provide a near real-time product of methane because they have a time delay in the cloud information that we get from SOME MPP. In case we are becoming independent of SOME MPP, we could also provide a near real-time methane processor. We are working on it. To be realistic, we don't want to oversell. We can finalize this by the end of next year. We're also working on improved sulfur dioxide algorithm and on methane, this I've already mentioned before. I got some slides also from my colleague on Sentinel-3. Here, as mentioned before, 2 satellites are flying in normal operations. Launch date for the 3rd satellite is already being planned. Here, the ground segment is shared between EUMETSAT and ESA, and I think there will be more information later by my colleague from EUMETSAT. The basic distinction is one agency is working on near real-time and the other on offline data. Here, just few examples on a few products that at least my colleague told me are important for CAMS. It's on land surface temperature, on a fire radiative power. I just showed this as example. Here, another example for application, important also for atmosphere. It's on aerosol information derived from Sentinel-3 data, but it's just another example and a nice image. Coming back what I've mentioned at the beginning, and it's my last slide, we are having this activity within Copernicus on contributing emissions. What we are doing here, we are started a specific activity on interact with a new space. There's really a lot of things are going on, and on atmosphere, really a lot on methane. We are working with GHGSat, it's a third-party mission, but within Copernicus, we started 2 projects on methane with the new space companies Absolute Sensing and Satlantis. And there will be pilot projects on using this data with CAMS. So the big difference here on these new space companies, we are working with, as mentioned before, with GHGSat, is a Canadian company. But in combination, for example, with Sentinel-5B, you have a spatial resolution of Sentinel-5B of about 7 kilometers. And with these missions, you have a spatial resolution of 30 meters. You don't have the coverage like Sentinel-5B, but you can combine the data. With Sentinel-5B, you can detect something, emission over Madrid or coal mines in southern Poland. And with these satellite measurements, you really can zoom in. So this is something new, and how this really works out, we are starting now, but we are spending quite some money on this. The first beneficial user will be CAMS, it's clear, but we're also starting to talk with IMEO, and as it has been mentioned before, methane monitoring is becoming more and more important. And I stop here, and thanks for your attention.
Thank you, Klaus. I think we actually might have time for a question, if there are any. No? All clear? Okay, then we will move on to EUMETSAT and Federico Fierli. If we can get, and your presentation is there.
Yes, thank you very much, and thanks for the patience. Thanks for inviting us, and also to Klaus to provide the first part of the space segment. So I'm Federico Fierli, and basically I will provide you which is the status of the atmospheric composition space segment that we are working on in EUMETSAT, but also providing you some elements on the user engagement, the user uptake and training that Vincent-Henri has just introduced in its presentation. So I will start with Sentinel-4, Sentinel-5 and CO2M. So they have been introduced, but you are probably aware, I mean, you know about these missions that are absolutely crucial for the present and the future of atmospheric composition. Sentinel-4 will be the first one providing a continuous observation on geostationary orbit above Europe, and is hosted on the Meteosat third generation sounder. And here is an example of the is a design of the satellite. And the Sentinel-5 will be the continuation of Sentinel-5 precursor. I mean, as the name says. The status is that we are preparing for the launch, and the launches are are planned in the 2024-2025. We shouldn't hide the fact that there are issues with launchers at European level, and I mean, this is a big struggle not only for us. But what we are doing is that we are working on user preparation activities. So to work properly with the users, that is a large community that we are also seeing here in part. We are working on the preparation of Sentinel-4 with the qualification of the instruments, and also very importantly, we are about to kick off the Calval activities. That is a crucial part where there is a strong engagement of the community. Then we are about to publish a preparation of announcement of opportunity together with the European Space Agency. Will be a joint activity where I mean, all of you, we really hope that all of you will be part of this story, because it's a joint effort. And also there are discussion and work in focusing on which are the key observational networks for the validation. And in parallel with also developing tools and software. I will mention CO2M. CO2M is also a constellation, so is a composition of a series of spacecraft. The objective is to contribute to the upcoming CO2 monitoring service that was just mentioned before. And I mean, the kickoff in WMO is a big step in this direction. And the CO2M is one of the components of the data chain, and it will be a very important source of observation. Not only for CO2, but also for ancillary products like nitrogen dioxide, but also cloud and methane. These are the specifics that are quite challenging, in fact, and the objective is really to attain a precision of 0.7 ppm, I mean, to monitor precisely the distribution of CO2. And as we say, that this is part of a complex chain that is the CO2 monitoring validation, verification support capacity. I will mention something about what is already in orbit and what is already working, what we are already providing. Klaus introduced the Sentinel-3. This is the near real-time product, and this is an example of the recent fires in Alberta, in Canada. This is the beginning of the fire season, and you can see the fire radiative power and also the smoke plume that was produced. And all these data sets are available on the EUMETSAT, the new EUMETSAT data store. So it's in data.eumetsat.int. And these are, as we say, the near real time, so are available with the latency of a few hours. And the same with the aerosol optical depth, that as you see here, this is the new version, is the version 3.0 that has improved the capability to observe over ocean and also over internal waters. As you see, for instance, as an average here of summer 2022, the capability to observe above the Caspian Sea, but you also observe a plume of aerosol north of Spain that is due to the intense wildfire activity in that period of the year. We also provide and support CAMS with the data sets that are synergistic. So this is a PMAP. We are still talking about aerosol. Here we also have the capability to distinguish between different typology of aerosol. And this is a collection of the different instruments that are flying on the APS, on the EUMETSAT Polar System. And here we have two activities. One is near real time. And you see, for instance, one snapshot in the bottom left, but we have also recently released a data set that is a climate data record and was provided to the CDS, to the climate data store of C3S, and is a reprocessing based on the last 2007 to 2019 years. And you see here in the below part the continuity and the homogeneity of the time series. Still talking about data sets that comes from supporting missions in EUMETSAT, I would like to mention recent products from the ACSAF. So ACSAF is a service from EUMETSAT, is atmospheric composition satellite application facility. ACSAF works with CAMS and sees CAMS as a primary users. So it's very important to the interaction between these two bodies. And there are three types of products: near real time, offline, and also the production of data records. And this is one of the most recent. So is a new climate data record that is based on the GOM2, and GOM2 has a continuity since 2007 with the first metopay. And this is our level 3 datasets, so our gridded datasets, just released 1 month ago, validated, and they cover ozone, nitrogen dioxide, formaldehyde, bromine oxide, sulfur dioxide, and water vapor. So please do not hesitate to come back to us to work on. Reprocessing is an important contribution that we also try to have with CAMS. This is an example of the newly reprocessed GOM2A NO2. So just to see that there is a big difference between what we have as offline as a reprocessed in orange. And below you see the table where of the data sets that we are providing through the ACSAF or through the Secretariat to CAMS for the next generation of the reanalysis of EAC5. Fortunately, we have the first EUMETSAT that is flying, has been successfully launched in end of 2022, December 2022, and these are the first images of FCI, that is a flexible combined imager. This is a fire above Central Africa, and you see that with new resolution that is about 800 meters, we are able to observe the dynamic of a fire, and here. I don't know if it works. It's a video. I don't know how to launch it. Okay, here is it. This is 1 day of a fire that you see as a small dots, and on the top left, the larger one is the one that we have just observed before, and this is a big change. The data will be available, hopefully, soon, September to October. This is our target date. We are in the validation phase, and this will be for us a very big complement with the composition data sets for the wildfire monitoring in Europe. Based on that, there is a big activity that we are working on. We have started also together with CAMS about the usability and the user engagement. These data sets are complex to use, are not easy, because there are many technicalities, and also they are less straightforward than the data that comes out from the services. And then we are working on improving the data usage. I will be very fast on this. What does it mean? It means that we work on tools to support the user and data handling. We work on testbed. This is an example of, again, on wildfire, and this is how to prepare the user on how Sentinel-4 will be, for instance, during a wildfire event. This is during the Greece wildfire in 2021, also having interactive tools and using different type of data sets and forecasts in order to see how they combine and how the data chain works. We work on the engagement, again, together with CAMS, with the CHEMS on the wildfire monitoring, and we have a series of workshops and discussion with the main user and the operational users around Europe. Training, as mentioned before by Vincent-Henri, we have joint activities of training, but also very specialized activities, for instance, on dust monitoring. We are also starting to work with Africa. There is a very strong need in terms of satellite data uptake due to the fact that ground-based observation are missing, and we also work on case studies and stories also a lot with CAMS. This is again an example of the Canadian wildfire with a comparison between the GOM2 aerosol and the CAMS forecast, and this is an example on the right part on the new GEMS observation that are a very good proxy for what we expect with Sentinel-4. This is an example of NO2. I stop here, just mentioning the Wikio platform and recent activities that we had on EO data visualization that was also very well participated with a lot of contribution from the Copernicus ecosystem. I stop here and I thank you for your attention.
Thank you, Federico. Next up, we'll have a talk on air quality observations from Sara Dominguez Serrano and colleagues, it says in the program. Okay.
Okay.
From Tracasa.
Okay. So thank you very much for inviting us to this CAMS General Assembly. We are really blessed to be here and to share with you our work and how we contribute to this great community. This is CAMS 2022. We are Tracasa. So first we will give you a brief overview of our company, Tracasa Global, and we will review in more detail some of the key aspects and objectives of this project. Tracasa Global, well, it's a public technological company of the government of Navarre in Spain, specialized in high value-added businesses in land management, spatial data analytics, and geographic information systems, both in Spain and abroad. Our mission is to develop knowledge, people, and innovative services in collaboration with public administrations and private companies in order to contribute to the quality of life and to the sustainability and security of our planet. We provide services in fields such as agriculture, environment, territory, emergencies, water utilities, infrastructures, Earth observation downstream, and artificial intelligence applications. Some examples. We work on data quality control and validation, spatial data search and transformation processes, advanced data analytics, and the main projects related to those examples and related to air quality, which is the matter here in CAMS. We have a framework contract with the European Environment Agency for different IT consultancy services in the area of spatial data flow development, management, and cooperation. And we also work with you, ECMWF, collaborating on the CAMS 222 to improve the provision of up-to-date observations at the European level in terms of air quality. Okay, so these are our main objectives for this project. We are increasing in situ data coverage, in situ observations, acquisition of them, and the performance. We are upgrading the data reporter system, enhancing the tools used by most of you and users who want to take this data. And, well, we also have some different phases where we will improve data quality and for sure give you ECMWF and contractors support on all our activities. So I think this slide gives a good overview of what we are doing. Thanks to CAMS projects, we've been able to accelerate this process. In orange, you can see the countries that have been included since we work for ECMWF, so mainly many Eastern Europe countries, Italy, Iceland. We are currently now focused on putting all our efforts on taking UTD data from other countries such as Albania, Montenegro, and Turkey. And we also give special support to the United Kingdom since they left Europe. We are not only trying to get more and more data from different countries, but also improving the data coverage within the country. So this is a good initiative to take data not only from the official stations, which is the picture at the left, but also from other local administrative stations, okay, which is the picture on the right that gives us an idea of the improvement. key in this project is to be prepared for the future. We are now processing about observations from about 6,000 stations around Europe, but we already know that this might explode, okay? Because maybe sensors and other devices may send us data and we have to be able to process them. Okay, so we are migrating to a more reliable, more scalable and cloud-based infrastructure. We are preparing for that. And this will mean that we will be also providing immediate availability of the data. And just some figures to say that in a traditional database, the full data set, for instance, is about 500 gigabytes, and using Parquet files, Parquet data in Azure, which is the infrastructure where we are holding this data set, we are talking about only 15 gigabytes of data. So it is really compressed, it's really prepared for data analysis, it's a step forward. Here just two examples of the improvements in terms of the tools used by data end users. We have released a new section under the AEA status webpage that covers air quality, well, the main air quality services, and give you a very brief and clear overview of the status of each of them. And the second one is a really interesting work we are currently doing to provide an enhanced download sites. Some of you might have used the old systems, but we are working hard on the new site. It won't be only as a download site. We will also provide an API for you to query the data, to filter it, to get the most of the data. These new downloads will reduce bottlenecks and the waits that sometimes happen in the old system. Also, as I said in the previous slide, immediate access to the data, high availability. It will be a really reliable system. Some of you might have also noticed about this other site, this other viewer, is their quality index viewer. Sorry for that, I think the slide is not working properly, but we have hourly data sent from the different member states, and as some of you said before, the time series are not complete, okay? This is an issue, and what we do right now is to use statistical methods based on CAMS forecast to fill these gaps, okay? Within this contract, we'll explore other state-of-the-art techniques, new models, machine learning, etc., and the newest CAMS forecast developments that you are currently doing to improve this index continuity. And for sure, we give you support on the different air quality products. The UTD viewer, the air index viewer that we saw in the previous slide, on e-reporting, the download systems. If you have any comment, feedback, request, or if you detect any issue, you might contact our help desk, or for any other project-related matters, just contact me on that email. And thank you very much.
Thank you, Sarah. Any questions to this talk? No? We'll discuss it maybe in the break then. So our last talk for this opening session is on ACTRIS data. And Paolo Lage, please, the floor is yours.
Thank you very much. Thank you for the invitation. So I will present the two contracts that are connected to ACTRIS. And I don't know if you're aware, but since April 25 this year, we have the European Commission accepting the ACTRIS European Research Infrastructure Consortium. So we are now a legal entity, which is funded by today 17 countries, perhaps at the end of the year 19, and which is called ACTRIS ERIC. So I'm the chair of the ACTRIS, and Eya Urola is the interim director general of ACTRIS ERIC. The membership to ACTRIS actually funds some of the activities that we have in the research infrastructure, basically the head office, the data center, and what we call the topical centers, which are basically the calibration centers of the infrastructure. Instead, the ACTRIS, for the national facilities, the sites, they receive the funding from the member countries. So it's a commitment to continue funding the operation also at national level. It should be fully operational in 2026, even though we have already many of our services in place. The organization of ACTRIS is, again, with this European dimension, the ACTRIS topical centers and the ACTRIS data center. And then we have the national facilities, which are based on one side, the experimental facilities, so mobile facilities, atmospheric simulation chambers, and on the other, the facilities observation, which are the sites that I'm going to talk about. And for the sites, we have the two different kind of techniques, the remote sensing and the in situ. And the network for our observational facilities is as follows. So we have about 60 stations that are providing in situ aerosol and trace gases. Some are also EMEP stations, some are also GO stations. We have 30 reactive gases in situ. Again, some are EMEP stations, some other are GO stations. We have about 40 aerosol LiDAR stations. All are early net stations. And also to be mentioned in this, and you see that in the graph, that not all facilities have the same instrumentation in operation. It depends. The Pallas Sodankula station is the station with most instruments available, both for the in situ and the remote sensing. So it's really depending on the station. So we have actually, we constructed ACTRIS not on an empty landscape. And when we've been talking about observational networks, you all know these networks. And actually, ACTRIS is actually bringing a commitment from the countries to continue the operation in Europe to provide support to those networks. So we are connected to Aeronet. Obviously, the users are going to find their Aeronet data at the Aeronet website. But inside this data flow, there is the Aeronet Europe topical center, of which EUMETSAT is part of, which are making the calibration for the international network. EarlyNet and CloudNet are embedded in ACTRIS, while the in-situ surface is also connected, as mentioned, to EMEP and to GO. And the two contracts that we have with Copernicus are actually on the CAMS 21 number, and we have, this is the second phase, with CAMS 21A connected to the aerosol and reactive trace gases in situ, and CAMS 21B connected to the LiDAR profiles. So I will describe a bit those two contracts. What are we providing to the community? Basically, all the two contracts are about developing the near real-time provision of data with the high quality. ACTRIS is really the high quality. And so we have the development of the software, we have the testing at the selected facilities, the implementing the architecture with the data center, and then training the users. When I say the users, it's mostly training people to operate the near real-time softwares at their own stations. And then the upscaling to the full network. And so which kind of, we are not going to do that for all the 150 variables or more that ACTRIS is actually providing on a yearly basis. We are going to do that only for selected variables where we have the most maturity. So you have the variables that are listed here. On the upper side, you have the variables that are connected to CAMS 21A. And on the lower side, you have the variables connected to CAMS 21B, so the LiDAR profiles and the in situ. In the middle, you have also, within CAMS 21A, a connection and a participation of EMEP with especially the PM, the O3, and the NOx provision of near real-time data. I'll come back to that. So this is the overall organization. Then I will go to the status of where we are now. So for this aerosol in situ, so we started already back with the first phase, and so all the NRT software developments are done. We have tested these developments at selected facilities. There are still some adjustments to be done because it's not so easy to control the quality, the high quality near real time. And we are working now on the NRT architecture, the provision of data, the training of users, and the upscaling. So you have here the stations that are actually able to provide this information from CAMS 21A. And you have this visualization software for the chemical composition. So this is the chemical composition. This software is not yet open to public. It will be open to public with the final architecture that we will have. So this software will be migrated to the ACTRIS data center and offered and open to everyone to see where the data is, which kind of data we can provide, and eventually download or get the information, push the information to Copernicus. So this is what we have there. And I would like to mention the fact that this software that have been developed, they have been asked by our colleagues in the US within the Ascent network and with NOAA. So all what we are producing in CAMS 21A is interoperable with what our colleagues in the US are doing. So at the end, you will have products that is totally usable, whether you're in Europe or in the United States. For the reactive gases, we are starting now, so it's not as advanced as for the aerosol. We are starting the development of the NRT software for selected VOCs. So I indicated the selected VOCs. They have been chosen by the Topical Center on Reactive Gases in ACTRIS. This is the first part of the work. The second part of the work is the fact that ACTRIS is actually working with a specific measurement procedure for NOx, which we consider for remote stations a bit better than the classic one. And the idea would be to demonstrate the added value of looking at, of measuring NOx and transferring this NOx data in near real time with this ACTRIS procedure with respect to the normal procedure. And you have here the kind of error which you have when you compare the two kind of procedures for a site which is a bit outside of Paris. And so you see that you get to a 20% difference. The third action in CAMS 21A is something that is connected to the previous talk of Sarah. On one side, you have what actually the connection, the data that you get. On the other, you have what EMAP is actually producing. And we are trying to see what would be the added value of making sure that all the EMAP data are actually provided to in this kind of Tracasa connected data flow. And so this will be an action there to see where we can have an added value through the EMAP monitoring network to the CAMS. Finally, I'm with the CAMS 21B now. So CAMS 21B has started also a few years ago. This is the second phase. The idea of the second phase is really to continue working on the software development. We know how complicated LiDAR operation can be if you're working on near real time. So these are, on the left side of the slide, the improvements that are scheduled for this second contract of ACTRIS. So you see that we will be working on data products that will be much more reliable. There will be also in ACTRIS CAMS 21B some work to make sure that the assimilation of model is made easier, so to facilitate that once people will be using this information. And this will be for 11 of the sites of the 40 LiDAR sites that we have in ACTRIS. And these 11 sites are actually EUMETSAT sites. So the idea, I should be careful presenting this slide to Vincent Henry. The idea is that at the end of the first phase of the second CAMS 21 phase, we'll have this kind of information available from this number of stations. I think it's feasible, and we are working on it. So to finalize this, all the data from ACTRIS are actually available on a regular annual basis, but we are working on the NRT data provision. I think it's really important also for the ACTRIS data providers that they can provide this information near real time to check their own data in near real time, and this is how we sell it within the ACTRIS community. And so these are the participants to the two contracts, and with that, I'm finished with this presentation. Thank you very much.
Thank you, Paulo. Any, yes, questions? I'm not sure. Yes, we have a microphone. Perfect.
Hello, I have a question about the NDAC network. You showed that NDAC was one of the 6 networks in ACTRIS, and I believe that NDAC contributes to CAMS, but I didn't see it into this CAMS 222. Yeah. So can you explain how NDAC goes into that?
So the truth is that, so I asked Martin de Mazière, obviously there is a contract specific to, with the provision of NDAC data to CAMS. It's a long one. I mean, it came with North and the follow-up. It's not an ACTRIS connected contract because the CAMS contract with NDAC is a global one, as for CAMS and possibly GO in the future. So obviously it includes some of the ACTRIS information, but it's not only ACTRIS, so this is why it is not mentioned there. So I'm only presenting this CAMS 21A, 21B, but obviously NDAC is also providing, as NDAC, some information to CAMS. Yeah.
Thank you.
All right. Other, okay, yes, another question.
Okay. Do you know if the EarlyNet NRT distribution will be shared with the e-profile from EUMETSAT, including the GTS distribution?
Well, so in ACTRIS, we are sharing some information which may not be exactly the same for e-profile. For e-profile, we are sharing the information for the automatic LiDARs rather than the research LiDARs. So we have the connection with e-profile. ACTRIS is providing to e-profile, but it's not through this contract. So you get the ACTRIS information to e-profile as well. E-profile is quite big, and so ACTRIS is a little chunk of that for these automatic LiDARs.
All right, if there are other questions, I think we'll have to take them in the coffee break. Thank you, Paulo. Thank you to all the speakers in this session. The General Assembly is now really officially opened, and we'll have a coffee break until 11. So see you back there then. Thank you.
Okay, thank you everyone for making your way back in from coffee break. Please take your seats. Thank you. Thanks very much. So we're now going to start the second session of the plenary this morning. It's a session on surface air quality. My name is Martin Sutty. I'm head of production at ECMWF, and it's a pleasure for me to chair this session. So we've got 6 talks to get through before lunch. So if we could just start straight away. And our first speaker is Gail Collan from Météo France, and she'll give us some updates on the CAMS European air quality. Thank you, Gail.
Thank you, Martin. Okay, so let's start with this update on the CAMS European air quality, and we will also going to present the next steps. So, next slide, please. Oh yeah, sorry, I forgot. Thank you. The CAMS European air quality is a pioneer system in the air quality sphere. I'm not going into details on this slide because you already know it for most of you, but it's very important to remind, as Vincent said this morning, that this is a unique Europe-wide operational air quality service. Maybe just important to remind you that we have 2 kinds of products in our production. So first, the near real-time products. Basically, that is forecast analysis, which are produced daily. And we have some reanalysis also, interim and validated ones that are produced annually. I would like to highlight the fact that the CAMS European air quality is a robust and reliable service, first of all. And today especially, I mean, yes, I think it's just today, this week marks 1 full year of production with a multi-system, now constituted of 11 regional systems. If you remember, last year at the GA in Bonn, we were proud to announce the fact that 2 new models joined the pool of the ensemble, Mini and Monarch, the model from the Italian and Spanish institute. And this was really a significant improvement, as now Southern Europe is really represented with this addition of these 2 new models. And what is really also important to focus, to underline, is the fact that the service performance remains robust even with 11 models. I'm just showing you this graph. You can see in blue the number of times that we have calculated the ensemble with all the model. So you can see that in blue you have, you have the before June 2020, and after it was with 9 models, and after June 2020 it was with 11 models. And at the beginning we have a slight decrease of the production, but it's getting better and better now, and we are again matching the KPI, the key performance indicator, which is to calculate the ensemble with 11 models 85% of the time. And in pink, you have the number of times the ensemble has been calculated with 7, then 9 models, and it's still very, very good, reaching 100% nearly. Something interesting to share with you also, because you can see it, it's really internal to the production teams, is that the fact that the system works well because we have developed a lot of monitoring tools. This one is an example of a pre-operational tools. This is CAMS Visu. It's a web-based visualization tool that is used by, that is shared with the modeling teams and the CAMS management, and it is really useful to compare a production, an operational production, and the first visualization of what we call the integration production, the development production actually. So it's really efficient. Another tool is a monitoring dashboard. we have developed also 3 types of these systems to monitor the observations availability, the number of models participating to the ensemble, and the model availability in the archive data. Just to let you know, well, this is a very good example, 10 days in a row with all the modeling system contributing to the ensemble. Very good, it was not that long ago. And also, just to let you know that sometimes some models are not able to participate to the ensemble because they are a little bit out of time, but they do calculate, they do provide their outputs, and so we don't have any missing data in the archive. So that's important also. Okay, so we saw that CAMS European is robust. We also want to highlight the fact that it is a multi-service success in CAMS. Why? Because yes, we are talking sometimes about CAMS 240, but actually CAMS 240 is fully embedded in the CAMS sphere. CAMS 240 would not exist without the other service. So here you can see at the upstreams all the service contributing to the inputs to CAMS 240. So of course the chemicals, met conditions, the wildfire, the anthropogenic emission, and the data from EEA, and soon from ACTRIS data, as we have just seen this morning. The upstreams, a lot also of links with the production of CAMS 240. We've got, of course, the Copernicus user support, the atmosphere data store that provides directly the users, the policy support, and the CAMS user intelligence. On the right part, you know that we have very strong links with regional evaluation and quality control. And at the left part, we wanted to remind the fact that we are also a development, an R&D service, because we use outputs from the CAMS, the Copernicus 1, CAMS 61 and 63 development service. And we are in strong relationship with the CAMEO system. So everything works well because CAMS regional air quality is also an ensemble, I would say. Okay, now CAMS European Air Quality is, of course, an evolving service. This is a kind of timetable of the different upgrades that we have in the past and the next upgrades that are planned for the future. I would like yes, just to let you know that we had an important upgrade in the fall, November 2020, with the addition of 2 new parameters, the formaldehyde and the glyoxal. This was in November. The next upgrade that was initially planned in the spring has been postponed to November, and in November we will have, in agreement with the CAMS management, and in November we will have a major upgrade with the addition of 2 new parameters, PM 2.5 SOA or maybe OA, addition of sea salt, and especially we are going to use a new a new emission data set. So we will use now the recent year emission provided by CAMS 261. This is a major step for us since it allows us to use emissions with a reduced gap, so between the data of the emission and the data of the production. So it will be now only 1 year gap between emission and production. And just also to say that we have added an intermediate upgrade. This is why it's named U7B. This is just to mark the fact that we have to adapt to the technical, well, we have some scientific and technical adjustment to the upgrade of the IFS, the CAMS Global, and the GFS. So that's also important because it doesn't change, of course, the products that we are sending, but there is quite a lot of work for the modeling teams to adapt. So it was important to underline that. So after this November U8, I'm not telling now because we will mention it last year. I was talking about the evolution of the CAMS ensemble with evolution of the modeling systems. But we also would like to underline the fact that we have also new projects in the CAMS air quality regional sphere. We are adding model output statistics. So that is going to be introduced next week or the week just after. And so Augustin is going to present about it in the next presentation. Also, another very important new item in this CAMS regional sphere is the work on the addition of an optimized ensemble. We are working to implement the fuse calculation method that was developed in the CAMS 63 project. So I won't go into detail because this will be in my talk, I hope, next year. And finally, as I said previously, CAMS regional is not only operational, but it's also an R&D project. And we have some long-term R&D activities paving the way for continuous development of the system. We have 3 studies that have been conducted or are being to be conducted. The third one, the forecast initialization, will start in October. The satellite data simulation, you will hear about it, or you have already heard about it in the Cameo session. And I'm just going to give a few words on the deposition part. So what is the aim of this study is to evaluate the deposition of the key pollutants, 4 key pollutants. So we compare the simulation of the concentration from regional systems, and we compare to the observational data from different networks. Here is an example of the total deposition for COV, for NOx, for the whole year 2018. And in black, you have the observations. And the basic conclusion is that we can identify some common behavior of the regional models. And we can also identify some specific behavior. And this really helps for identifying ways for improvements. That's all. This presentation was given on behalf of the CAMS 240 service team. You have all the name, all the member in this. As you know, we are a really big group, and thanks everyone, but we really wanted to thank all the CAMS partners. And as I said, and I think it will be the key message from this presentation, the regional air quality works because there is this strong relationship between all the different CAMS services. Thank you.
Yeah, thanks very much, Gail. Maybe we've got time for one question, if there is one. Burning question from anyone? Don't see one. Okay, you're off the hook, Gail. Okay, our next speaker is Augustin Colette from ENERIS, and Augustin's going to give us a few highlights of recent achievements related to the air quality forecast. Thanks, Augustin.
Hello, everyone. Thank you for giving me the opportunity to present 2 highlights. So one coming from CAMS 240, the production, and the other one from the policy service. I will start straight with this one. So Gail mentioned it briefly. We introduced this in this service, a very innovative way of improving the air quality forecast by using basically machine learning technique, combined with the CTM, the chemistry transport forecasting, to make the best of the regional forecast and also to make the best of observations. I think it was already presented in the introduction of Vincent Henry. It's quite important that CAMS actually is on several steps, and observations are a very important part of the process. So we started this development in a former contract, which finished a couple of years ago, CAMS 63, and we demonstrated that there was a very substantial improvement for the detection of the peaks. So basically, the way it works, several bullets in a nutshell in the bottom of the slides. We didn't start straight from CAMS 63. It's true that we've been operating such statistical bias correction for more than 10 years in the French air quality forecast system. But we had to adapt to a very specific item in the CAMS system, the regional system in particular, is that we have 11 models, and we have regular upgrades, like just mentioned Gael. Every once or twice a year, we are upgrading the system, and we don't have the freedom to recompute a multi-year calibration system as being done statistically for most of these bias correction techniques by many forecasting groups. So that's why we had to introduce innovative techniques using a regularized model and also designing a very short training system in order to adapt to this specificity of the CAMS forecasting system. So what was expected is to provide as output hourly forecasts at thousands of surface stations distributed over Europe for the 4 main air pollutants. As predictive variables, we use, of course, the CAMS regional ensemble, of course, the observations that I just mentioned, and also some meteorological predictor. And then we design this daily automated training on the basis of only the past 3 days, and that can only be done if you design your statistical model as a unique model over the whole of Europe. Any statistical correction that was done in the past was actually correcting individual stations one by one and defining a model for each of the European stations. And that is really the novelty that we introduced in this, in this design in order to adapt to the CAMS specificity. So a couple of equations just for fun, but saying that maybe basically we've been trying 3 different types of methods. The first one is very basic, it's just a simple linear regression. So that is the type of models that have been used for many, many years, but that have this problem of requiring a long training data set. Then you have the regularized regression, which can adapt a bit more to more shorter data sets by introducing penalty coefficients in several ways so that the model is not too overfitted. And then, of course, we have this type of hierarchical model, classification trees, random forest or gradient boosting, which allow the model to define its own structure and do this classification. This is also just for fun to give you the numbers, but don't expect me to go through the specificity of all this, and this is documented in the paper I mentioned. I put a link before. Just wanted to highlight that we've been trying very many different types of models and trying to assess their performances in different ways. But what is important is what is written on the bullet point on the right-hand side. So we have this requirement to produce hourly MOS. But at the same time, we know that there are some statistical methods which are more performing better if they are trained just for the daily mean or the daily max. We have this huge issue for air quality forecasting of detecting threshold exceedances. And it's true that we will have to choose a model which is not really optimal because it produces hourly data. Second point, I mentioned it a couple of times, we have an operational constraint. We have to use a model which can work with a short training period in order to adapt when there is a shock basically in the production when you have an upgrade. And then we selected the models depending on their performances both for regular score, like root mean square error, so to say average scores, but also the ability of detect the peak. So the table is just here to say that we had to make a trade-off between all of these criteria. We made a decision at the end, but we are also mindful that it's not the end of the story, and we might need to go back to this choice in the future, and maybe even rely on a multiple set of statistical forecasting techniques. This is supposed to be a movie. I think it should start, or if not, no. But just an example of the application of the MOS over the past week, basically coming from the CAMS Visu website that Gael mentioned before. And again, this is the plot that were presented in her presentation, showing that there is quite an improvement for detection of the peak. And we are just starting to experiment that benefit in the production over the past month. We tend to present this capability in terms of performance diagram showing the ability to detect the peaks, so the probability of detection on the y-axis and the success ratio on the x-axis. The ensemble median, so the standard CAMS 240 median is the turquoise diamond, and then over the past couple of months, we've been able to increase quite a lot the success ratio for ozone with the red dot. But we know from the development work we've been doing in CAMS 63 that the target performance is actually the blue circle that I introduced on the figure. And we hope that after the summer, we will be able to come back with a more thorough evaluation specifically adapted to ozone peaks. Just to conclude on this part, just wanted to say the status today is that we are about to deliver this MOS output at individual station on the ADS. We have to be very aware that in producing this, we introduce a new criticity in the system provision, and this criticity is the availability of the in-situ data. And it's true that over the past few months, we had like a few weeks a period when the access of EEA data was difficult. And if we want to produce relevant MOS, we need to secure really the access to those. And the presentation of Sarah from Takasa just before is illustrative of the work required to do that. Then there is also future development which would be relevant. Here we are just putting in operational mode a development that was done in CAMS 63, but we know that there are also a lot of work being done in that respect with a more innovative machine learning technique, and also perhaps added value diagnostic. And I'm just showing an example of the French forecast system when we are relying on an ensemble of MOS, but also a probabilistic forecast of the risk of detection itself. So we are not forecasting anymore just the average value, but giving a probability of the risk that at that station on that day, we will be above 50 micrograms per cubic meter. So it's not an example taken from CAMS, but just to show that there is a wealth of various work that can be initiated in that respect now that we entered this work of machine learning for the air quality forecast in CAMS. And the last point was mentioned by Gaël, and we will be working later this year together with FMI on the optimization of the ensemble maps. So the MOS is only for the forecast at station, but we have to produce also the maps. I have a second topic for which I will go quite quickly. I'm sorry for rushing through the slides, but this is coming from the policy service. And I wanted to highlight that we've been, for the first time, starting to explore really the future, the 2050 type of timescale, by simulating emission scenarios, with a specific focus on methane scenarios. Methane is a priority topic for policy at the moment, of course, to assess emissions, and many of you are very knowledgeable, much more than me, on this topic, but also to assess the benefit of methane mitigation for ozone in the context that the United Nations Air Convention might revise the Gothenburg Protocol in the near future, and this revision could include targets for methane. So we know that methane has been explored a lot in global climate, global modeling community, but not so much for nested versions, so using a global model which is properly nested in an ensemble of regional models. And in CAMS, we have the perfect setup to actually do that. And that's why we've been working with the colleague at ECMWF to do a nesting on the IFS simulation with 3 regional models. The type of results we are showing is basically for Chimère, Lotos, and IMEP, 3 regional models, and on the right-hand side, the IFS. We have the base of the ozone annual average maps, and then the difference when we move to the current legislation, so not so ambitious, and if we move to maximum feasible, when we have much more ambition in the amount of mitigation strategies. And the problem, obviously, here is that if you do just the current legislation, there are quite a few areas when ozone annual average will increase by 2050. Sorry for this. And then, so we've been, of course, comparing the regional and the global scale models. And quite interestingly, we found that actually it's the global model which exhibited the largest spatial variability compared to the regional model. That was clearly not expected. The resolution is not the same. So we expected the IFS to be a bit more smooth. But actually, in terms of gradients overall in Europe, especially if you look at the average value by country, we find that the IFS overall has larger gradients, both for ozone peaks and for ozone annual average. This is a very complicated slide. I think I will have to skip, and I will just jump to sorry. There is a full report available on the CAMS website. I'm sorry but for the interest of time and the other speakers, I'm jumping to the conclusion. Just wanted to highlight that in the CAMS service, we have the strengths to be able to run regional models nested in a global model, and that is very relevant to support policy and produce this future scenario modeling, which is especially relevant for methane, which is a priority topic at the moment. There is this issue, of course, we have a lot of methane evidence from the global models, but it's relevant to actually extend that to the peak and the exposure to ozone, both for health and for ecosystem, and that is best done with the regional models. Overall, the conclusion, and I think it's quite reassuring, is the fact that the EFS is within the spread of the regional models. It's quite reassuring in the fact that the modeling community is converging in the diagnostic, even though there is a larger variability in IFS also in the model response. Just to conclude, this last slide on the novelties that we introduce at the moment in the policy service, various items. Again, we have a one-stop shop for all the policy products we are developing in CAMS 71. It's policy.atmosphere.copernicus.eu. We just published the interim assessment report for the year 22, thanks to the very hard work of colleagues at NIDU. So the report is already available on the website. We are very, very close to add shipping in the air control toolbox. It's in pre-operational phase and the result is satisfactory, and we will move that to the operational version in the weeks to come. We are also about to publish 2-episode reports to analyze the PM episodes we witnessed in Europe in the February-March. We've done a full revision of the website, also adapting all the guidance and adding a frequently asked questions section to better explain what we are producing in these policy tools, because it can be sometimes confusing. And that's also part of a very strong focus we are putting at the moment to strengthen the collaboration with Fairmode, and in particular GRC, to do this guidance on the source apportionment, but also to work on the discounting of the natural contribution. And with that, I want to close and give a perfect transition for the presentation of Leonor in a minute from now.
Okay, perfect. Thanks very much, Augustin. We could have a quick question in between the transition, if there is anything. But I don't see any, so thanks again, Augustin. So yeah, next speaker is Leonor Tarasan from NILU, and Leonor's going to tell us how to take account of desert dust in reporting PM exceedances. Thanks, Leonor.
Okay, thank you very much. Surface air quality is really very much related to European legislation. And this is an activity in the policy support tools development team at CAMS, where we want to make sure that the CAMS products are really used for policy development and in response to the air quality directives. So although I am here as the organizer of this part, it's really this accounting for natural sources of desert dust when we report exceedances of limit values under the air quality directive. It's an exercise that involves everyone. So I'm really very interested on this area, and it's very nice to see that we have a context. We have an air quality directive that in the Article 20 now, but it is recovered in the proposal also from the European Commission for a revision of the air quality directive is Article 16. So we have the articles there that say, if your exceedances are due to natural causes, you may reduce the level of exceedance. This is extremely important for member states, and it is really a key issue, what it is the reason of the exceedances of the limit values. To understand that, or to understand how to do it, the Commission developed a guidance in 2011. This is a long time ago, and at that time, CAMS was just beginning, and the CAMS products were not available. There's no reference whatsoever in the guidance that member states have to the CAMS products. So our intention here is to propose best practices and to look at the way the CAMS products that we are developing on dust can be used for policy. And to do that, then we have linked the CAMS activities with Fairmode. Fairmode is a forum for air quality modeling under the air quality directives. It's the place really where the analysis of exceedances is discussed and taken new methodologies in place. So this is the background or what we're trying to do. And then the cooperation, the full group is INERIS, the Met Office, Met Norway, TNO and NILU. We're all working together with Fairmode and with the member states in order to assure that we can develop some best practices, how to best use the CAMS modeling dust products or the ones that were produced in the context of the air quality directive. We want not only to use these best practices, but really to produce some recommendations on how to use it. We are aiming that in the end, if there is a revision of the guidelines of 2011, that then CAMS comes into the new guidance with a clear reference on how to use it. That's the ultimate goal, but we also feel that by doing that, we increase awareness of what are the CAMS products. We also learn as CAMS producers which ones can be used and which ones not. And we really want to make sure that this is an exercise of co-creation where we all learn from each other, and experiences from other countries can be useful for the different participants. So what we have now is that we have launched it. We launched it, in fact, in April this year. And it is an activity that will go through the whole of 23, and we hope to finish it in 2024. We have by now 37 participants, people that are interested in that. And the interesting thing is that we have already 13 countries. And those are the countries that have shown an interest. It's interesting that Norway is also interested in this, because we don't expect that there are so many Saharan dust intrusions there, but it is really a part we want to analyze. And as you see, it's mostly Southern Europe that it's interested, Southern and Eastern Europe. What it is interesting also is that the Spanish team involved into the analysis is the responsible team for making the 2011 guidelines that are purely based on observations. And that's the group of the SIC in Xavier Querol, and we're very, very pleased that he wants to participate too, because that's really a way to continue doing a development of those guidelines. We have, of course, ECMWF, but also WMO in the dust activities at WMO, and the EEA following closely. And we see that this can have a potential impact really for the future. So what we are asking people to do is to select an episode in 2022. That's very timely because now they are reporting exceedances on 2022. So if they do it, that identify one where they think there is a dust contribution, and then do their own analysis, as they usually do, on how do you deduct the Saharan dust. And once you have this, carry an additional evaluation with specific CAMS products. Compare the two methodologies and come with your findings. So we'll have a possibility of coming back and having some recommendations and some exchange of experience on how to use it, how not to use it. The point here is that we want to compare with the current methodologies, and we are not aiming at this point with any of compliance reporting. It's really simply a free space to share experiences. These are the exceedances that we've seen. There is a huge episode in March with very specific large exceedances all over Europe. It's interesting, the colors here. They are from Eastern Europe, Western Europe, Central Europe, Southern Europe. There are all the parts having exceedances, and those are created not only by dust, but many different causes. So the idea is that we have a target that will be 22 because it's the reporting year, but we want to be flexible because different countries will have different times of the episode coming and being interesting for them, and we want to be flexible on what are the analyses that people want to do. What we have now prepared, and Agustin already mentioned it, we have this episode, the interim annual assessment report that has an analysis of the episodes. And the episode of March 22 is already described there, so that can guide those that are participating also on how to use it. So what we've done then is to share the data, and there are many different products. So that by now we have 5 different products that are looking at dust under CAMS. We have the CAMS regional interim reanalysis data. We have the regional dust forecast. We have the source receptor calculation in European cities. We have a chemical speciation in European cities, and we have the global data. The analysis then is we present the data and we let people be free on interpreting. We don't want to be prescriptive on how to do it because everybody learns from from doing it by themselves, and then we learn from each other when we get there. We've developed a viewer, and here you have the viewer presents the different projects, the different data. This is the dust fraction of the 15th of March last year, and we have the global ensemble data, then we have the regional ensemble data for the same situation, the one that it is with the reanalysis, and the data that is for the full of PM10, just to compare the two, what's that and no dust. And this is a viewer where you can get the different days, you can look at the data, you can see how it is, and then you can download it afterwards. We have the hourly data from the web pages that are developed to understand the dust component, and there in yellow again, it is the episodes where you can get the dust contribution from those. And then INEDIS has been very helpful on providing all the hourly data at the stations that people are reporting. So it's all the stations at the EEA where we have the data in Excel. Some people having problems with NetCDF yet, so by now we're doing it in a very simple place so that everybody can upload the data from Excel and just look at the time series and interpret it. So the time frame, we began, as I said, in April. Now, next week, on Tuesday, we will have the first interpretation meeting. Those interpretation meetings are nice because usually the first one, it only comes 3-4 groups. I've already been flagged that they are doing some analysis. The others hear it, and then we have the whole summer to think about it. And we'll meet them again on the 4th of October, which is the CAMS Policy User Workshop that we have back-to-back with Fairmount. And we'll have a full session, a full morning, where we'll be able to discuss the experiences and exchange ideas. Then we will decide if there's a need for additional experiments, and we'll come back at the plenary, where we will have some recommendations then on the future revision of this guidance on how to do these dust products. So we hope that this can be interesting. If any of you here are interested in this, please contact us. Come, anyone at the CAMS team or the Fairmount chairs, please contact us, and we'll be able to put you in the team because it's really an open place where we can discuss. So thank you very much for your attention.
Thank you, Leonor. Great. Again, there is a bit of time for questions. Okay, we have one. Excellent.
Okay. Thanks for the talk. So I'd like to ask you for CAMS users outside Europe. Is it possible to join the project? Because we also see Saharan dust coming to Latin America, for example. And in the air quality networks, we observe these huge amounts of PM 2.5, PM10 when we get probably 2-3 days a year, but we get Saharan dust overseas, and it's affected most major air quality cities in cities in Latin America.
In fact, it would be very nice if you want to join. The problem is that then you have only one product. It will be the global. But it can be interesting also to see how do you feel about the global one, and we can. What is important is that you tell us what it is, if you need the data or if you can download it by NetCDF, so that we can facilitate your analysis. So please, the global in South America would be great to look at.
One more, Augustin.
It's a very nice topic, and actually in France we are already discounting exceedances for the Caribbean islands using the CAMS Global, so we can also help to make this link.
Okay, so thank you very much, and thank you, Leonor. So following on from this, we now have Michael Gauss from Met Norway, and Michael's going to inform us about evaluating the surface air quality forecast following fair mode. Thanks, Michael.
Thank you. So this is, as was mentioned, about the evaluation of the regional production of CAMS. Fair mode has been mentioned a couple of times already, so I don't need to explain what it is. In working groups 2 and 3, there's a focus on how to test regional models for a given purpose. So in this case, assessment, analysis for past years, and forecast. And these are the two things I'm going to focus this presentation upon. I don't have time to explain you all the theory behind the fair mode metrics, but just one equation, the MQI, that's a very central concept. The model quality indicator, that is just the ratio between the root mean square error of the model and the measurement uncertainty. And we want that indicator to be as small as possible. So it's kind of counterintuitive to require that a model quality indicator has to be as small as possible, but it's just the way it is defined. And fair mode wants us to have this MQI below 1, equal to 1 or below 1. Oh, there's another screen down. It's more convenient for me. And that model quality objective should be below 1 for at least 90% of all its measurement stations. And you see there is a, sorry, there is a, sorry about that. There is a factor to determine the stringency of the model quality indicator, and that has always been 2, as far as I can remember. That's a fair mode recommendation. So we want the root mean square error of the model to be within twice the measurement uncertainty, which sounds reasonable. And this is the first result I'm showing you. This is for the ozone 8-hour moving average daily maximum for summer last year. And each dot here represents one measurement station. And the location of each of these symbols is determined by the mean bias at that stations, plotted in the vertical, and the centralized root mean square error. That's just the root mean square error after the bias has been removed. So the bias-free root mean square error. And the statisticians among you will see immediately then that by plotting it this way, the distance from the origo is exactly the model quality indicator I had on the last slide. That means the root mean square error scaled by twice the root mean square, the measurement uncertainty. And the model quality objective is that 90% of all the stations are to be within this unity circle. And, or put in a more fancy manner, the 90th percentile of the MQI is supposed to be 1 or smaller. So you actually need to, if you have very little time, you only need to look at the MQI 90 value. That has to be below 1. And that means that the purpose, or that the model is fit for purpose. And in the case of the ensemble, the CAMS ensemble, that is always the case. We happen to meet the model quality objectives for all species, for all seasons we have looked at so far. I have to mention this is the assessment model quality objective, and I will show the forecast model quality objective in a minute. This is the analysis. Just to show you that the analysis is better, which is according to expectations, because we use measurement data to optimize the model result. For more advanced users, you can distinguish between the model quality indicator different performance indicators. That's the bias norm, it's the correlation norm, standard deviation. You can also look at the high percentile norm. And again, if you have very little time, all you need to do here is to check the dots on the right-hand side. If they are all green, then the model is fit for purpose. If there are red dots, then you have to look further into this. And you can see here one red dot. That's for nitrogen oxide hourly means. We miss, actually all the regional models miss the high percentile for NO2, and that's because this is particularly difficult to model. As most of you probably know, the air quality standard for NO2 is related to hourly means. We are not to exceed 200 micrograms for more than 18 hourly means per year, and that related to 8,760 hours in a year. That means that we are talking about the 99.8th percentile, and that is very hard to model. So we are talking about the very highest peaks in NO2. Indeed, we may not even want to model them correctly, because remember that our grid cells are typically 80 to 100 square kilometers, and those exceedances, they usually don't cover that large an area. So this is where downstream services, downscaling becomes important. They will probably do a better job on that high percentage norm. Now about the forecast indicator proposed by Fairmode. When we talk about forecasts, we especially want to model sudden changes in concentrations levels correctly. That's the episode start and end dates. And we want to reproduce the exceedance of thresholds correctly, because they are policy relevant. And just before I show you the last two slides, this you have seen many, many times before. This is the contingency table. FA means false alarms. This is when you model an alarm, but it's not really true. And MA is the missed alarm, when you have an alarm, but it's not modeled. And this is the Fairmode target plot for the forecast indicator. And this looks very similar to the target plot I showed you a few minutes ago. But here what we plot is the mean bias of the model divided by the root mean square error of the persistence model. So you see at the top, it's a slightly different definition of the MQI. You don't relate your RMSE to the measurement uncertainty, but to the persistence model. So that means yesterday's observations. And this is a little bit harder to meet for models, but it turns out that the CAMS ensemble meets all the forecast indicators for all the species. That's the 4 species. There are a few individual models that don't meet them. PM is particularly challenging, so we have some seasons where we don't meet the MQO for the forecast. One more point I wanted to make here is that the MQI actually gets smaller with the forecast day. So you see here on the right the MQI for the forecast MQI for different species, and the MQI gets better. As I told you, MQIs should be as small as possible, and it almost looks like the model gets better the further into the future you go. That's of course not the case, but the persistence model degrades faster than the forecast model, because yesterday's observations, they lose their importance the further ahead in time you get, while the models have, after all, the advantage of using forecast metrology, which is quite accurate on a 4-day horizon. The last slide I wanted to show you, and this has already been shown by Augustin, it's the performance diagram. That's another Fairmode type of plot that we are showing. So in the vertical, you have the fraction of correctly modeled exceedances among all observed exceedances, and on the horizontal axis, you plot the fraction of all modeled exceedances among all correctly modeled exceedances over all model exceedances. That was tricky. Last year, I showed the same slide last year. I told you that everything should be as close to the upper right corner as possible. The dots are moving. We are approaching the optimal, but as Augustin showed, CAMS 61 has come up with a circle, which is our target on this plot. We are approaching that, but we are not quite there yet. So in terms of exceedances, we still have some job to do, but again, I point out the regional resolution of the CAMS models. So we will probably always have a hard time in getting local exceedances right. So in conclusion, we are using Fairmode. It's not the only thing we use, but it's part of the regional evaluation work. The ensemble meets both the assessment and the the forecast objectives for all the 4 species and for all seasons. Some individual models have problems, and especially when it comes to very localized exceedances, we cannot expect always the regional models to correct this correctly, to model this correctly. Okay, and if you want to see the forecast MQOs in our reports, you have to wait just 2 more months, and then you will see them in the MAM 2023 assessment. That's for spring this year. Okay, thank you. 5 seconds more. Thank you very much.
So yeah, thank you, Michael. Yeah, we have some time for any questions. Not seeing any. Okay, thanks again, Michael. So yeah, next speaker is Mark Guevara from BSc. Mark's going to give us some updates on the regional emissions. Thanks, Mark.
Yeah, so thanks a lot for, sorry, this is one. Thanks a lot for the introduction. It's indeed a pleasure for me to give you an overview of the recent works we've been doing on the regional emissions, but also on the interactions that we have within and also beyond CAMS. And this is a talk that I'm doing on behalf of all the different teams working on the regional emissions. So this is mainly TNO, who is the contract leader of the CAMS 261, but also FMI working on the shipping emissions, and BSc working on the temporal profiles and also service evolution. But actually, there are many more teams involved in the CAMS 261 emission service. So we have an emission core service where we look into the CAMS anthropogenic regional emissions, shipping emissions, as I was saying before, but we're also producing products at the global scale. We have the natural global emissions produced by Charles University, also with contributions from Chalmers when it comes to volcanic emissions. CNRS is in charge of the CAMS anthropogenic global emissions, and there will be a talk later tomorrow by Claire talking about this topic. And then we have 2 other work packages outside of the emission core service. One is led by BSc, focused on service evolution and support to the CAMS production systems. Another one led by MEDNO, it's basically focused on user support and documentation of the service. Today, I will basically focus on the squares that are highlighted in red, so the anthropogenic regional emissions, shipping emissions, but also this connection that we have with the outside world. So now diving into the regional emissions, the main product that we produce there are the CAMS regional, CAMS reg European anthropogenic emissions. This is a product that is produced by TNO and uses as much as possible official reported data, the official inventories that are reported by countries to EMEP and UNFCCC. But of course, to ensure completeness and consistency of the CAMS emission product, in some cases, some sectors, some sources of these official estimates are replaced by most up-to-date, state-of-the-art and robust data sets. And this is the case, for instance, of the shipping emission. In this case, we use the data set produced by FMI using the STEAM model, which takes into account automatic identification system data that allows estimating emission at the vessel level. For the other emissions that are provided by official estimates, TNO basically apply a consistent spatial distribution so that it allows us to produce gridded emission maps, such as the one we can see here of a roughly 6 by 6 kilometer resolution. Here I just put a list of the 2 last versions of the products that have been recently released. So we have the CAMS reg version 5.1, which spans from year 2000 until 2018, and then CAMS region version 6.1, which covers the years 2019 and 2020. And it's something that it's important to highlight. One of the limitations that we have is that there is always this 2-year time lag with official reported estimates. So this year now, they will provide emissions for 2021. And of course, this is a limitation, especially when these emissions want to be used for forecasting activity. But we have handled this situation and we have managed to find a way to reduce this gap. And actually, Gael briefly mentioned about it. I will talk more about later on. So as I was saying before, one very important concept is consistency. We want to ensure a good consistency in our CAMS emission products. And in the case of PM, we have an important issue there because usually emissions are not reported consistently because of the inclusion or not of the condensable fraction. And this is very especially important in the case of the small combustion. So here I'm talking about residential, commercial combustion activities. So in order to reduce this inconsistency, TNO developed a bottom-up science-based inventory that we commonly refer to as REF2, in which the PM emissions and the condensables are included in a consistent way, basically using same emission factors in all countries, and of course considering local activity factors, and also, for instance, information on the share of type of appliances that are used to burn wood. And here in this figure you can see a comparison of the total emissions reported by this REF2 emission inventory in blue and the official estimates in orange. And we see that in non-European countries, the inconsistency or the discrepancy between the two results, it's especially important, especially like, for instance, in Turkey. But in Europe, more and more, the results get quite closer. And this is because more and more countries are including condensables in their official estimates in the recent years. And it's basically a result of ongoing discussions and awareness that were raised in the framework of different forums and projects. Still, we see uncertainties and discrepancies on some countries because we still need to work more and try to further refine the approach. As I was saying before, the shipping emissions produced by FMI using the STEAM model are part of the CAMS-REG product, but they are not used only for CAMS, but also to support the European Maritime Safety Association. And this is done by basically producing some tailor-made products which consist, in this case, of gridded CO2 emissions that are provided for different domains, different sea regions, and different types of ships. And this, again, can be done because of the specific type of data sets that are used as input data. And here in these figures, you can see basically the distribution of total annual CO2 emissions in the Mediterranean Sea. In the one hand, you see it for roll-on, roll-off passenger ships, so these are mainly ferry ships. And on the other hand, you can see it for container ships, and you can clearly see that the spatial distribution of each product is completely different. So in the first case, the busiest routes, for instance, are the ones that are connecting the peninsular Spain with Balearic Islands. And in the second one, we can see that the busiest routes are, for instance, the ones that go through the Strait of Gibraltar, or, for instance, the ones that are connecting the port of Valencia here, or Barcelona with other international and European ports. Another important aspect that we're working on, so the CAMS-REG emissions are provided at the grid cell level, but these are annual total emissions. And of course, for air quality modeling, we need them to be broken down into a much finer resolution, ideally at the hourly scale. And to do that, at the BSC, we have developed a data set that we call CAMS Tempo, which basically allows to disaggregate these emissions using different emission temporal profiles that take into account the influence of meteorology and also socio-demographic factors. And here in this figure, basically what you can see is an example of the results that you can produce when combining the CAMS-REG inventory with the CAMS Tempo dataset. These are daily PM2.5 emission in Spain for the year 2021. And in this color, we are representing a different emission source. So in yellow, we have the residential commercial combustion source. And you can see that the largest peak of emissions were occurring at the beginning of the year, which coincides with the impact of the Filomena storm, which provoked an amazing drop of temperatures across almost the entire Spain. And of course, then more people were using heating appliances, and therefore emissions increased a lot. So one important aspect of the CAMS 261 service is that we are not only producing emission products, but we are also making sure that we have a two-way dialogue with the CAMS regional production service, so that we are aligned between the products that we develop and the needs of this group. And one of the wishes that they had, it's try to use as much as possible more updated emissions for the forecast. As I was saying before, we have the issue of the 2-year time lag. And actually, this has been now solved by TNO, basically producing an extrapolation technique that takes as a reference point the official reported data, and then from here they extrapolate that information to more recent years, basically considering activity data, proxies, and trends in emissions. So now we have two different new products, the emissions for year 2021 and 2022. First one will be used for the reanalysis, and the second one, as Gael mentioned before, will be used for production starting in autumn. And here in this figure, you can basically see a comparison of the normalized NOx emissions for each country and each sector. So the left bar shows you the reported official emissions for 2019, and the right bar shows you the emissions that were extrapolated for the year 2021. You can see that for most countries, there is a reduction of NOx emission. This reduction mainly comes from a reduction of road transport emission, because as you can remember, during 2021, especially the first quarter, there were still a lot of COVID restrictions affecting mobility, especially in some countries such as UK, Spain, or the Netherlands. So it's clear that the CAMS regional emissions are a pillar of the CAMS regional air quality production system, but it's also a well-established brand. It's a reference for many European and international projects and initiatives, but also for national air quality modeling efforts. And here, for instance, I'm putting as an example the EUMETSAT air quality forecasting system, which uses as input the CAMS regional emissions. And the good thing of this usage of the CAMS regional emission in different projects is that they are either normally used to produce other new products, or they are also used as a benchmark to compare against other independent emission products that are developed within these products. And of course, this gives us a unique opportunity to really learn from the feedback that we get and improve our CAMS emission products. And I will just give you a couple of examples of that. So the first one, it's an intercomparison work that we are doing in the framework of the RAI Urbans project. Basically, the idea here is that we try to improve as much as possible the representation of emissions inventories in European urban areas. So what we did is to compare the emissions that are reported by CAMS RED in different European cities against independent bottom-up emission inventories that were collected and that are being produced by independent local authorities. So in this scatter plot, what you can see is the comparison for NOx road transport emission. Each point, it's one city, and what we can see is that almost all the cities are below this dash red line, which basically is indicating that there is a slight general underallocation of road transport NOx emissions in the CAMS REC inventory. So this might point to maybe some potential uncertainties in the spatial proxies that are currently being used, and it's something that we will try to review during the next years. But of course, it's also good to see that there is a very good consistent overall. Another example, it's the type of intercomparisons that we are doing, for instance, under the SEEDS project. It's a project that was briefly mentioned before by Vincent and Henri. And here, it's a type of intercomparison in which we are not comparing bottom-up against bottom-up, but actually bottom-up against top-down. And what we are doing basically is to compare the emissions that are top-down emissions that are produced by the DEXO system, which is developed by KNMI, against the CAMS REC emission. Of course, this gives us an advantage. First is that in the case of NO2, for instance, you can see here comparisons also in different cities, but in this case, we can not only compare total emissions, but also gridded emissions. So we can see comparison of the distributions. We can see, for instance, in London, more or less, both the spatial patterns and the total emissions look quite consistent. In Madrid, Paris, Rome, we tend to see CAMS REC reporting less emissions. But then another very important aspect of comparing bottom-up and top-down emissions is that it gives us the opportunity not only to compare grid emissions, but also temporally distributed emissions, so therefore to evaluate also the CAMS Tempo dataset. And here you can see an example of that. In this case, it's a comparison of monthly ammonia emissions at the national level produced by DEXO using the CRIS observations, and these are compared to the CAMS REC, CAMS Tempo observations, and we can clearly see how in many countries the CAMS REC plus CAMS Tempo dataset allows us to correctly capture the peaks of ammonia which are occurring in different parts of the year, and this is basically due to the different types of crop calendars that are in different nationals. And last but not least, I just wanted to mention also an emission benchmarking activity for quality control and quality assurance that we recently launched in the framework of the Fairmont activities that were also mentioned before by other speakers. And in this case, the CAMS REC is again another pillar for this type of comparisons that we want to do. So there are basically two types of tools that have been developed. The first one, it's what we call the emission dashboard. It's basically to monitor the progress and identify inconsistencies among regional inventories, but also between versions of the CAMS REC inventory. And the other one is the emission composite mapping, and basically the goal here is to be able to compare regional and bottom-up inventories for different regions, and here you can see an example of this comparison for Pollen, for instance. So, of course, all these interactions that we have beyond CAMS, sometimes they raise inconsistencies, but I think consistency is actually a great door for the change and for the progression of our CAMS emission products. So thanks a lot for your attention on behalf of the entire CAMS 261 team. Thank you.
Okay, thank you, Mark. And yeah, we can take questions if there are questions for Mark. Again, I don't see any. Nope. Okay. So we're coming to the, sorry, thank you, Mark. We're coming to the final talk of this session. So it's Mikhail Sofiev from FMI, and Mikhail's going to tell us all about the CAMS pollen forecast. Thanks, Mikhail.
Okay, thank you. Let's hope there will be slides. Yes. Thank you very much. So this is pollen-related developments, a little bit special part of regional forecasting. So I'll say a few words about the current state and show some evaluation of the activities within regional CAMS forecasting. And we'll also say a few words about the supporting developments, because one of the features of Copernicus, which was already mentioned several times here, it centralizes the developments around it. And this is what is happening in the bio-aerosol world, and I'll say a couple of words about that. So let's first set the terms. So when we talk about bio-aerosols, we should keep in mind that till recently we were calling them organic carbon. So whenever we do measurements of traditional ways, do some mass spectrometry, we see organic carbon. But in fact, it is present in all size ranges, and what we do see there is actually all these guys, starting from proteins, viruses, bacteria, spores, and pollen. And so far, we are concentrating on pollen inside CAMS, because that's probably the longest and the richest data set available for this particular type. But we are also thinking about other parts. So what we have now comes to 14 European regional ensemble. We predict 6 species. Those which are in green are those for which we have measurements. And this is done by 11 models, so that's what you've heard already several times. Daily predictions, 96 hours, so all the standards of regional air quality, they are here at full. And for this period of CAMS, for CAMS 2, the work is concentrated on consolidation of the ensemble. We know that there are more than 6 species in the air, but the idea is to make these 6 working as accurately as we could make it. And a big help in this part is the observational data, which comes from European Aeroallergen Network, that's EIN, a unique creature in the world, which is a bottom-up, privately run network, which agreed to provide their data to CAMS for evaluation of the models. For now, we have the data from 21 and 22, for 2023 only until May, because this is the network which is running 70-year-old device, which was invented in 1940s, until today is the state of art of measurements of pollen. So there is manual procedure. We get the data with large delays. But once again, there is nothing better than that till recently. I'll say a couple of words about that. And for the retrospective evaluation of these 2 seasons, we used it mainly for internal efforts, by making the models better and cleaning out all the issues in every specific model, because the whole story is pretty complicated. What we have now, for instance, these are the 4 species for which we have the data and correlation coefficient for the CAMS ensemble. Basically, well, we know this 0.7 is a magic number which we all would like to reach. In quite a few places, or in most parts of Europe, we actually reached that. So that's the bottom line, that the ensemble is reliable and it reaches sufficiently high correlation to be used in routine basis. And I should confirm that for last year, maybe in health circles, this product is getting its respect. Let's put it this way. Where we stand in more difficult parameter, which we never saw before until we come into this bio-aerosol business, is the start of the season. When pollen starts flying, this is what every allergologist wants That's what every allergy sufferer wants. Because when the season is ongoing, concentrations are high, it doesn't matter anymore. But when it starts is a question mark. In the changing climate, it does start in different moments. We see changes in start of the season compared to 20, 30 years ago, exceeding more than a month. It actually starts earlier. In some cases, it starts even later. So climate change can work in mysterious ways in biology. And the left-hand side map is the shift of season, which our models report is the error of the ensemble. As long as it's yellow or yellowish, it's perfect prediction. So it's a good sign here on the left, but on the right is what doctors actually want. They say, folks, it's very nice that you can predict the season. Yes, we see that you predict strikingly well, but we want to know not only when the season starts, we want to know when concentrations reach level relevant for medical purposes. They call it clinically relevant season start, and that's a different story. There might be seasons if trees do not pollinate or grass is not pollinating, too much rain or too dry, then season might not even reach the level of clinical relevance. That will be 0. And there, as you can see on the upper map, we are not that great yet. This is a new parameter which we are only starting to explore. In fact, the clinical relevance was introduced less than 2 years ago as an official output of task force of European Academy of Allergology and Clinical Immunology. They spent decades to figure out what this threshold should be. Now we have it, and now the question is how we will manage with it. And with this, I'm coming to new developments. First of all, what is happening now is in the existing models, those 6 species which we have, we can make them better. Some of them can be made substantially better, and the progress I already showed, and the work is going on there. And the second question is, pollen is comparatively large aerosol. We are talking about 10, 20, 50 micrometer size. It is light, it's not that heavy as rocks, but still. It doesn't fly too far. So regionalization is a possibility and a possible step forwards and possible way to improve the skills. That's the second part. And then the new models and tools. We are thinking about next round of Copernicus, where we will go once again to expansion of the species. We do hear it again from health professionals that we are missing these, and these species. So some of them will be added, and the work is going on with some parts, and yes, also for insects. Apparently, some of them are pretty nicely described by the same models. And last but not least, and probably the breakthrough I'll be talking about next couple of minutes, it's a near real-time observations. As I said, what we have now is pretty old-fashioned, let's put it this way, traditional instrument, which is de facto standard for already more than half a century, but there is a possibility to do it in a more modern way. So, but first, what does it mean to review the phenology and review the species? This is one of the comparatively new species. We don't have regular data from EN about it, but we do have some data from them. And the trouble is that in this traditional way of analyzing it, we do not see the difference between different species of Alnus. And there are, in fact, more than 10 of them, Alnusin, Canna, Glutinosa, viridis, whatever. So there is more than a dozen of them in Europe, and they do flower in different moments of time. And we do not see that because in microscopic analysis, all pollen of all these species looks the same. But when we start getting into time series analysis at the bottom, we do see peak from different of them. And from more detailed analysis, looking into DNA analysis, we can get these species one by one. And the trick is to make the model recognizing not a general alder, but every individual species of alder. That work was done for mugwort a couple of years ago, and current CAMS regional predictions for mugwort are actually based on 5 classes of mugwort. Next in line is alder. And the second part is zooming into subregions and seeing if we can get any better. For now, these are 3 different types of zooms. Left is CAMS domain, that's the European one, 10 kilometers, and the IFS operational meteorology. When we go to Northern Europe, there is a MEPS ensemble, operational once again, different meteorology. And for Central Europe, we can have ICON D2 domain from German Weather Service. So can get these three zooms. And if we go into the same skill, season start, can we do better when we switch to higher resolution? For northern part on the left, the regional one is blue. Yeah, here the chart, the closer to 0, the better. This is error of the season start. The green bars is European, blue ones is Northern European domain. Sometimes better, sometimes worse. Meteorology, change in meteorology sometimes appeared not to be very promising, so some work ahead. But the different situation is in zoom towards Germany, where you see that red bars, this is the regional simulations, are clearly better in predicting the season start. First, they resolve all the details of physiography of the country, and second, the meteorology seems to be pretty nicely fitting to the purpose. So in a way, we can go into regional zooms, and we can get better, but we need validation and looking carefully into the model to make sure that it actually gets better. And then switching to observations from the modeling part, this is the backbone of our operations because we are setting models basically from scratch based on the aerobiological observations. And here, sometimes I'm using the word revolution. For this part, this slide, I prefer game-changing, but that's what actually is happening. So there are a new generation of automatic bio-aerosol monitors. They are getting mature gradually. There is a new breakthrough just this year. We first got the LiDAR algorithm for pollen identification. So for some pollens, we actually see 3D now. And that's just a couple of months old situation. And the next one is eDNA sequencing, which used to be skyrocketing in terms of prices and very slow. With the third generation of sequencing methodology, we can get them not in real time, but in near real time. It's gradually becoming possible and also affordable in terms of prices. And yes, with these technologies on board, we can start seriously thinking about spores and even some bacteria, especially with the eDNA approach, that might work. And that opens the possibility for the modeling, the real-time data assimilation, which has its own caveats. I have no time to discuss that one, but it has to be a very special assimilation of model parameters. So one of the big projects which just started since February and since January, this is called Silva. The kickoff was in Palace just on February, and the station was already shown by Paolo. It was summer photo. This now is winter photo, how that station looks in winter time. And that's one of the places where the northernmost device automatic device is being installed just these days. There are people working on the roof yesterday and today. So we will soon get the data from that station. And the idea from all these red dots, which are here on that map, is to get the data in real time. And that's a task for Silva. And then another project, actually a series of projects, there are at least 3 I can mention, but there are maybe a couple of more on the way. Somehow it happened that European Commission and also several regional developments put some funding into spores straight. And all these projects are about spores. Global in coverage, regional in specifics, and the ultimate outcome, at least of first 2, to get the spore forecasting model. And the third one, the life plan, it's an ERC grant which started less than 2 years ago. It's the global ambition where all these red dots here are the DNA-based analysis of spores all over the world. So many of these stations, in fact, are already operational. So we are coming to something really big in terms of measurements as a summary for this. And the impact will be going way beyond allergy. We're going about agriculture, we're going about talking about forest, and spores in particular are very valuable there. So as a final slide, the steps forwards. So in CAMS 240, we keep going our consolidation efforts within CAMS 2. So we will keep improving the models, and that goes mainly through the identification of model by model. When something goes wrong, figure out why, and get rid of it. Data assimilation of automatic devices, that's a strong part of Copernicus. This is where we know and we have huge background, so we can do this part happening. So that's the development then. CAMS 93 evaluation, near real-time evaluation against automatic devices is now seriously on the pipeline. So that's a new challenge, and we'll hopefully report a little bit of progress next General Assembly. And the retrospective evaluation, similar to what I showed, we yesterday had very detailed discussion on CAMS 40 meeting, and that will continue. And yes, the research and publication, they will also continue working. Thank you.
Okay, thank you, Mikael. And yeah, any questions on the pollen forecast for Mikael? I don't see any. Everybody's thinking about lunch, I think. Okay, if there are no questions, I'd just like to thank all the speakers again for a really interesting session on the surface air quality and for also keeping perfectly within the time so that you can all get to lunch bang on time. So thanks very much, everyone. Have a good lunch and see you later. Bye-bye.